Hello, this is Muhammad Usman, and today we are going to discuss a very technical topic, that is testing of hypotheses. Well, we'll start from statistical inference. Remember, when we study the introduction to statistics, we have defined statistics in two parts. That is, the first one was the descriptive part, and the second one was statistical inference. And today we will talk about the second part. It is a process of reaching conclusion about the population parameters and based on the information contained in sample. Well, in this slide you can see that population parameters, they are the true values but not observable. So what you do, draw a sample. Some sample is a small part of the population, well, and from that sample you make decisions about population, you make guess about population. And what are the quantities which you compute from sample is the estimates, that is x bar or s square. Well, testing of hypothesis is the part of the statistical inference, and it is a procedure to reject or do not reject any specified statement, and that statement is our hypothesis. And hypothesis may be an educated guess, it may be an assumption, or about what? Assumption or guess, that will always be about population parameter. Well, it depends upon your research objective as well. There are two types of hypotheses, null and alternative. As far as the formulation of hypothesis is concerned, you need to translate your objective of research or any statement or any guess into the mathematical form. And remember, your null hypothesis will always contain equality signs, whereas your alternative hypothesis will always contain inequality signs. And also you may note that most of the time your research hypothesis is your alternative hypothesis. And remember, alternative hypothesis is a complement of your null hypothesis, and the null is the complement of your alternative hypothesis. Now let's move on to the second step. It is the level of significance, and this we will call a probability of rejecting H naught when it is actually true, or we can say that it is the probability of type 1 error. Usually it is fixed at 5%, but it may be given, it may be according to your objective as well. Third step is the test statistic. We can calculate this value from the sample, and for testing population mean mu, we use t-test, and t-test, the formula for t-test is x bar minus mu divided by the standard error of x bar, and the standard error of x bar is small s divided by the under root of n. In this case, degrees of freedom is n minus 2. Step 4 is the calculation. Well, you need to calculate the x bar and the standard deviation and all those stuff, and then put all those stuff in the step 3 formula in order to get the calculated value of t. Okay, after this you should have some kind of decision rule that whether to reject H naught or not, and that decision rule depends upon the nature of your hypothesis. Well, I have written here 3 decision rules according to the 3 hypotheses that you may see in the step 1. If the first case, it is a two-tailed test, and the decision rule is you are going to reject H naught if the value of your calculated t is greater than or equal to the table value, or it may be less than or equal to minus that table value. And in this case you will see the table by dividing alpha with 2, and the degrees of freedom of course is n minus 2. And similarly the other two decision rules, they are there for your reference. And the last step is the conclusion. Well, according to the decision in the 5th step, you have to conclude your result and integrate your conclusion with your problem. Well, this is very important, and now we'll move to the example of it. Just this slide will show you that how the decision rule they work. This is a two-tailed test, and because it is a two-tailed test, then the decision rule contains two values which you have to look for. One is at the low end of the distribution, other is at the higher end of the distribution, and both the tails, alpha is being divided in both the tails. So in this picture, you can see that, and similarly third one. And the example says that 10 plants are chosen from a normal population and the height are found to be in inches, like the values are 63, 63, 66, 67, right, so on to 71. You need to test the hypothesis that the mean height of plants in the population is 66 inches. What? Your solution will start from step 1, and you need to formulate your hypothesis. Okay, the statement is saying that the population mean is 66 inches. So if you convert that statement into mathematical form, that is your null hypothesis, and you will have an alternative hypothesis exactly complement to that. Okay, the step 2 is alpha, that is 0.05, and the step 3 is your T formula, that is x bar minus mu over s over n under root. Well, calculation involves, you need to calculate the sampling mean, that is 67.8, and the sample standard deviation, that is 3.01. And you will put both of these values in step 3 to get the calculated value of T, and that is 1.89. Since it is a two-tailed test, so your Bayesian rule will be two-sided, and your table value in this case is 2.262. And the conclusion says, since the calculated value 1.89 does not fall in the rejection region, therefore we do not reject H0. And if we are not rejecting H0, that means the population mean is 66. Well, moving from single mean testing to the testing of hypothesis about the equality of two means. Well, the step 1 is the formulation of hypothesis, that says the population mean for both the groups they are same, and the alternative hypothesis H1 says that they are not same. Level of significance, the formula used for this purpose is, and you can see the rest of the formula on your screen. Well, S square of T stands for the pooled variance, and we will pool the two variances on the assumption that the variances in the population they are same. And the degrees of freedom in this case is n1 plus n2 minus 2. Well, calculation will come in at step 4, and the step 5, remember students, the Bayesian rule will stay same, and it depends upon the nature of your hypothesis. And at the last step, you need to reject or to retain your null hypothesis, and then integrate your conclusion with your problem. That is the most important part. Well, this is the T table for you, for your reference. In the columns, you're seeing the value of alpha, and the rows, you're seeing the degrees of freedom. And in the screen, you can see that if your alpha is 0.05 and the degrees of freedom is 12, your table value will be 1.782, like this. Thank you very much.